2 of our PVSOL webinars. Today we'll present you the planning in 3D. My name is Sixto, and I'm the host of today's presentation, and with me my colleague Thomas Medic. Hello, Thomas.
Yeah, hello to all participants also from my side. Hello to all participants from last week. After a short introduction, we will change live into the program and we'll show you the 3D visualization. Thank you.
Yeah, for those that are probably new here in our webinar, some words to our persons. We both have studied meteorology in Berlin at the Free University. Then we worked for a long time in the environmental research business, followed by a short period in environmental NGOs. And yeah, since quite a few years, we are now here at Valentin Software, and here we are responsible for the technical support. And as you can see, for the webinars and seminars and all this kind of stuff. Yeah, what can you expect in the next maybe 1 hour, 1 hour 15? We will again plan an on-grid system with net metering and battery storage. The planning of the PV system itself will be in 3D, and in the 3D visualization we will show a flush-mounted system and a roof-mounted system. Then we will repeat a little bit of the climate data selection tool MeteoSyn. We will also show the option load profile. So last week we showed you the import of a load profile. Today we will present normalized load profiles and how you can define one of these load profiles. And in the 3D planning we will also show you how to use your own textures for the buildings. Yeah. During the webinar, you have the possibility to ask some questions to us. Please use the chat function for that, which you can find on the right-hand side of your screen. We will try to answer as many questions as possible. But of course, due to the time limit and the number of participants, it will not be possible to answer all the questions. We apologize for that. So that's it for the beginning. Okay, let's start. This is the start screen of the program. No, that's not the start screen. This is the start screen of the program, the welcome page. Yeah, what can you see here? Maybe the most important thing here is in the upper part here, the icon bar, and this icon bar represents the workflow. And the workflow goes from the left to the right. And by clicking on one of the icons, you change the windows, and then you make your entries, and then go to the next planning step. You also can use the small arrow keys here on the left-hand side of the bar to navigate between the different windows. Yeah, I think that's it for the first page here. I don't know if you...
Yeah, I will repeat some options and setting at the beginning for the new participants. And yeah, I would like to start with the option here under the menu bar databases. Of course, here you will have access to all databases for batteries, complete battery systems, 2 types of tariffs, from-grid tariffs, feed-in tariffs, load profile, and of course, the main components, PV modules and inverters. We have a very huge database with more than 14,000 module types and 4,000 inverters. Yeah, and therefore it's very useful that here's an option, manage favorites. Yeah, and with this option, you can add your preferred modules or inverters to a favorite list, and that makes a selection of these components very easily. Yeah, and how does it work? First, you have to select your favorite here via this drop-down menu, and here are the favorite groups available. And yeah, we would like to show it for the PV module which we are using today. We have to select PV modules. Below, of course, you have to select the company. And today we're using a module from the company Hackard Solar. Then we have to search for Hackard. Here we are. Yeah, and then all available module types are visualized and listed below. And here you have to check or uncheck the modules which should add it to a favorite list. Yeah, just check here the box, and then it's added to the favorites. Yes, this is possible for different manufacturers, and as I have mentioned, for modules, inverters, batteries, and battery systems. Yeah, that's it for the databases, and now we come to the options. Yeah, under options, user data, here you are able to enter your company data, as well as you can import a company logo, which will appear on a cover sheet of your presentation and the following pages in the project summary header. Under program options, here you can enter the folder where your project should be stored. The project folder below, you have the choice between SI units, US units, and SI units with the American wire gauge. And yeah, here you can check or uncheck the automatic update check once per day at the first program start. Yeah, and then the program looks if a new database is available or a new program release. And here under reset, this is to reset your program, or you can do it separately for the program options as well as for the databases. Yeah, that's it for the beginning, and now we can start the replanning. And yeah, this we have to do on the next page here, the next window, and this is the project data window.
And this is for all the general entries of a project, like the project number, project designer. You can enter some customer data, customer address, and if the address of the customer is identical with the address of the installation, you can just adopt it by using this small arrow key here, arrow button. Yeah, on this page, the most important step is the start of operation date. Yeah. We click here on this small drop down, and then we select, okay, it's the 31st of October. You can also give the project a name. You can load the project image. You can see what we will plan in the next hour. Yeah, that's it for that page. Let's go to the next step. And this is for the selection of climate data and some entries to the plant system.
Yeah, well, here on the upper left-hand side, as mentioned, here you can select your climate data via a drop-down menu on the left-hand side for the countries, and on the right-hand side for the location, or the location nearest to the PV plant. Yeah, and if you would like to use a detailed selection of climate data, then you can open MeteorSyn, and therefore you have to click on this small globe icon, and then a new window appears, and here we are in a list view of MeteorSyn. Again, you have to select the country first, and then all available locations for this country will be visualized in the table below. These are the locations for Germany, and these data are based on the German Weather Service. All climate data outside of Germany are based on Meteor Norm 7. Yeah, in addition to these list selections, there's also another tab here, Map. If internet connection is available, then you are able to search for your location via this interactive map. Yeah, and here again, you have to select the country, and afterwards you are able to use this zip code search. And here you have to enter the zip code 80335. And if you click afterwards the start button, then the location you have searched for is marked in orange, and available data sets in the surrounding area are marked in green, with green. Yeah, and then you have to zoom in as far as needed to identify your location. And as you can see here, close to the orange marker, there's the green one. And yeah, to select this data, you have to click this green mark, and then the name of the location will be visualized. It's Munich in the southern part of Germany. It's famous for the Oktoberfest. And yeah, with the information about the global irradiation and the mean outside temperature. And to select these data, you have to click again its name, the link of its name, Munich, and then it's adopted with the averaging period from 1981 to 2010. Yeah, last week we have explained how you can create your own climate data. Therefore, you have to click the button here on the lower left-hand side, and then a new window appears. And again, you can search via zip code and location name. Yeah, and it's like the same as we have shown here. Okay, that's it for the climate data. Now we come to the definition of the AC mains. Therefore, you have to press the enter button. Then the AC mains window appears, and here you can enter the grid voltage between phase and neutral. It's 120 volt and 230 volts. You can also define the number of phases, 3-phase, split phase, and 1-phase. Yeah, and if you need it, it's needed. You can also define here the displacement power factor cosinus phi. This is a regulation, especially for Germany, but I don't know, maybe it's also needed in foreign countries. Yeah, no. What is also possible here, you can use the maximum feed-in power clipping. Again, specific regulation here in Germany. If you would get money from the government, subsidies from the government, then you have to use the power clipping here to 60%. 60% of the PV power you can fed into the grid, and then you will get subsidies if you use a PV system with battery storage. Yeah, and here's a 600 gram per kilowatt hours. This is the number with which we calculate the specific CO2 savings. But of course, in other countries, maybe you have to adjust this number. Okay, now we come to the type of design. Today, we have mentioned it. We would like to use a 3D design. Therefore, you have to check this box here. Then you will get a message that, yeah, all module errors you have defined up to now will be deleted, and also the configuration. Okay. And yeah, last but not least, we have to select the type of system. The system we would like to design today is pre-selected, and the other two options, this is a 3D grid-connected PV system with full feed-in, and a 3D grid-connected PV system with electrical appliances that you have net metering. And yeah, we will use system number 2 with a battery storage system. Yeah, now we come to the next page, and this is to define the consumption.
Yeah, that's right. Last week in part 1, we showed you the import of load profile. Today we used the option define load profile. So just click here on select, and then the new window opens. And yeah, what you can see here, this is a small bulb icon if you already have a load profile. So there's one preset here. If you want to create a new one, then you have to click here on the new load profile button. So then again, we click here on the bulb icon, and we enter a name. And finally, what you really need is the annual requirement here. Yeah. For example, 5,000 kilowatt hours in our case. Then you can define the weekend consumption compared to the weekday consumption. For example, if you have a factory building or something like that, and they are not working on the weekend, then you can define for Saturday and Sunday maybe 30% or 20% of consumption compared to the weekdays. Then, of course, we have to select one consumption profile. So there are some predefined profiles here. So in a lot, you can see them. Yeah, different ones from residential buildings, family homes, brewery, etc. School is surveyed, hospital. And we select here the residential average households from Berlin. So they're all measured from the Berlin energy supplier here. Yeah, click OK. And yeah, what does it mean? So what we use here is our so-called normalized profiles. Yeah. So we have entered the 5,000 kilowatt hours, and what you can see here, the normalized, they are all normalized. So all entries here are normalized to 100%. Yeah. So our 5,000 kilowatt hours are now divided into this percentages down to the hour. Yeah. So first step is the program checks how many energy is used here, for example, in January. So we had 5,000 kilowatt hours for the year, and now 10% of that, and we have 500 kilowatt hours which are used in January. Yeah. And then, of course, January has 31 days, and this 500 kilowatt hours are divided by 31 days, and we have, that's about 16 kilowatt hours per day which are used. Yeah. And now come the decision, is it in winter or it's spring, autumn, or in summer. You can see here there's different tabs, and let's go to the winter weekday. So this is for the weekday, and then our 16 kilowatt hours, which we have as a daily consumption, will again be divided into the percentages for the different hours. Yeah. For example, if you take a look here at 10 o'clock, it's 3.64%, and so it means about 0.6 kilowatt hours are used at 10 o'clock. Yeah. So you come from the 5,000 kilowatt hours to the for the annual value to the hourly value here. Yeah. So you can use this normalized profile if you don't have a measured load profile. Yeah. You can also define it here by yourself. You can see if you click on one of these values here, then they will be adopted in the small text field here above. Yeah? And here you can enter your own value if you have, for example, some measurements. You can also enter your kilowatt hours, and this has to be done for every hour, of course, and you have to define maybe the monthly values. And if you have entered everything, then you can click here on this button standardize, and then all your kilowatt hours values will be calculated as percentages, so that the sum will be 100%. So that's how it works. Okay. So we use this one here. What's left here on this page, you can also define holiday periods here. Well, if you are in vacation or something like that, and what's the consumption during this period. Okay, cancel, then we click OK. We close this window here, and now we have our load profile, our load here in our planning. Okay, let's go to the next step, and this is the real planning of the PV system now. So we select the modules and the inverters and all this kind of stuff, and for that we have to click here on the edit. So we go now. So we open now the 3D visualization, and a new window appear here, and the first is a selection of the building we want to plan.
Yeah, Sixten has mentioned, we have to select the coverable object, and here we have different options. We have simple roof areas with different roof shapes, rectangular, trapezoidal. We have predefined buildings with different roof shapes. You can also cover walls with panels, and we have two types of open areas, a flat open area as well as a tilted open area. Yeah, and we would like to use a building with gabled roof. You have to select the building, and afterwards you have to click on Start. And here we are in the terrain view. This is the first step in a 3D visualization, and the terrain view is to scale the building, to enter the dimensions of the building. And you can also add further coverable objects as well as shading objects in the surrounding area. And yeah, we would like to start with scaling the building, and therefore you can double-clicking the building or open the context menu and select Edit. Yeah, and here you have to enter for the story, for the ground floor, the width, the depth, and the height. And you can also enter the orientation of the building. And the width should be 15 meters, the depth 12 meters, and the height should be 6 meters. And here, via this drop-down menu, you can change. You can see it here. This is the ground floor. You can change between ground floor and story number 2. Yeah, and then it would be possible to enter also the dimensions for story number 2, but it's also possible to remove or insert further stories, and we would like to remove story number 2 because we have a huge height for the ground floor of 6 meters. Then we remove these. Okay, and then we change from the stories to the attic story. And here, of course, we have again to enter the width. You can see it here on the length of the wrist. Some meters are missing here. We have to change from 10 to 15, and then it looks okay. And what we have also to enter here, this is the position of the wrist. The position of the wrist, and this can be entered here via a shift of depth. If you remember, here we have entered for the depth 12 meter. And if you would like to have the wrist in the middle, that we have an equilateral saddle roof, then we have to enter here 6 meters, or you can also check here on the centered, and then it will be entered automatically. And then the wrist is in the middle of the roof. We have 2 roof wings with the same roof pitch. Yeah, here below, it's also possible to define a roof overhang for the gable end west and gable end east, as well as for the eave. Yeah, that's it for building number 2. And if we have entered all dimensions, we can close the dialog window. Yeah, and now we can change the texture, for example, here for the front view of the building, as well as for the roof. And how does it work? Please again open the context menu via right mouse click, and here is the option change textures. A new window appears, and here we are. You can change the texture for the front surface, left, right, and back surface in once, or it's also possible to separate these different surfaces, and therefore you have to check create textures individually, and then it will be visualized here separated. And yeah, we would like to change the texture for the front view or front surface, and we can use the texture from within the database. For example, plaster is now used. You can change to concrete, to wooden panels, to bricks, or to aluminium. And if you would like to use your very own texture, then you have to click this small icon on the right hand side, edit texture, and here there's a new button, and then you have to search for your texture on your PC. And here we are. This is a front view of a building. This I would like to use. This could be an image that you take with your digital camera or your smartphone, your phone. Only a front view picture from a building. This is here a front view for 2 storages. That was the reason because we have removed story number 2. This is a preview of this texture, and now we have to enter the dimension. And the dimension, of course, is like the dimensions of your ground floor. And in horizontal direction, it's 15 meters, and in vertical direction, it's 6 meters. And after pressing OK, here we are. Now we have a very realistic front view of our building. And now we change the roof tile color from red to black again. Here, do a right mouse click on the top of the roof, then select change texture, and here you can change from red ones to black ones. And very easy. Okay, that was building number 1, and now we'd like to add a second coverable object here within the terrain view, and this can be done via drag and drop. We have different options, and we would like to use a flat roof or a roof with a pitch here. With pitched roof, drag and drop it here close to the one with a saddle roof, and then again double clicking the building or do a right mouse click to edit the building and enter the dimensions. Okay, well, this is here in a mode complex, but for easy buildings, for buildings with flat roof, it's also possible to change this complex mode to a simple mode. Then you have to enter only the length of the eave, the distance from the eave to the ridge, the height of the eave, and the roof pitch. And you don't have to define the stories and the attic story separately. Okay, the length of the roof of the eave should be 8 meters. The distance from the eave to the ridge, 5.5 meters. The eave height should be 3.3 meters, 3.3. And we would like to have a small roof pitch of 5 degrees. So orientation should be the same as for the roof with the saddle roof, orientated to the south, 180 degree. 180 degree corresponds to south, 90 degree to east, and 270 degree to west. Okay, that we can set 0 here. 0, then it's in one line with the saddle roof. Okay, what we have to do now, it's very important, we have to add these building to coverable objects, otherwise it's only shading objects. Yeah? And after adding these to coverable objects, then it will be appear here in this drop-down menu on the top drop-down menu here, and here you can switch between both buildings. Building number 1 is a saddle roof, and building number 2 is a nearly flat roof. And of course, it's also possible to change here the textures to make it equal to building number 2. We change this also to black. And now we come to shading objects here in the surrounding area, and therefore we have available here 2 types of trees. It's the leaf tree and the pine tree, and also you can drag and drop it here in the terrain. Also the pine tree. And to define these, to edit these trees, just double-clicking the tree, and then you are able to define here the height of the tree, the height of the crown, so the diameter of the crown, the center of gravity, and the tree trunk diameter, and the difference between leaf tree, or deciduous tree, and pine tree is the transmittance degree. Here for the leaf tree, you will have a high transmittance during winter time, and during summertime, due to the huge crown, to the huge number of leaves, you don't have transmittance. Here will be a change between the seasons, and for the pine tree, there's no changing in the transmittance over the year. Okay, now we have to enter the dimension, 12 meters the height of the tree, 8 meters the height of the crown, diameter of the crown is still 5, not 50. 5 meter, 50 would be also possible. Center of gravity is 0.5 and 40 centimeter for the trunk diameter. And the position should be 5 meter in X and 4 meter in Y direction. Here we are. This was tree number 1, and now we change to the pine tree. And now we have to enter here the dimensions, and here this is 15 meters for the height. And it's 10 meters for the height of the crown, 2.5 for the diameter of the crown. Center of gravity, again 0.5. Tree trunk 0.5, 50 centimeters. And the position is 1.5 and 10 meters. Let's have a look to the transmittance degree. And as I have mentioned, it's the same for the whole year. It's around 27%. Okay, what is also possible, you can copy objects in a 3D visualization. Just do a right mouse click, copy, and then the clipboard will be visualized, and from within the clipboard via drag and drop, you can place further deciduous trees here in the terrain. And if you would like to create a small forest, then you can do multiple copies here. Then you have to check this box, and then the clipboard will be open as you have dropped all trees you want here in the terrain. Okay, we need also one further tree. Drop it here between both of these buildings, and now I have to enter the position, and the position should be, this was minus 19 is still okay, minus 19 and minus 6 meters. And here we are. Okay, now we have defined 2 different buildings and 3 shading objects in a terrain, and now we will focus on top of the roof and will define shading objects and part objects here directly on top of of the saddle roof. And therefore, we have to change from the terrain view to the object view. And then we will focus to the roof view south of the saddle roof. And here you have different options to define shading objects as well as bud objects. And yeah, you have the choice between chimneys and vents. You can drag and drop it. You have 4 different types of dormers. You have a fire protecting roof here. You have a single sawtooth roof. You have here a projecting roof as well as a parabolic antenna. And here in this area, this is for restricted areas. We have available skylights and restricted areas with different shapes. Here, this is a rectangle, trapezoidal, and elliptical. In case of flat roofs, you can create attics. If you have an industrial building, you can create sawtooth roof. This is a button to edit the edge distances here. Here, this cross lines. Then you can define maintenance passes and visualize or display the dimensions of the roof. Okay, now we have to edit these objects, and again, therefore you have to double-clicking these objects or do a right mouse click. And if you double-clicking, for example, here the chimney, then we can enter the bottom surface, depth, and the height of the chimney. And if you would like to refine the form, then you can also enter here the values for the top surface. You would like a chimney with a bottom surface of 0.4 by 0.4 meters. The height should be 1.2 meters. And here on the lower left edge, you have to define the position of the chimney, and point of origin is the lower left edge of the roof. And if we enter here 1 meter for X, this means 1 meter from gable end west in direction to gable end east. And 6 meter for Y, this means 6 meter from the eave to the lower edge here of the chimney. Okay, then we change to the parabolic antenna, double-clicking or edit. Then the corresponding window appears, dialog window, and here again you can enter the diameter of the reflector. The height of the reflector is also 1.2. You can change the orientation of the antenna from 180 to 130, for example, then it turn around. And of course, we have to define the position. 15 meters, again, it's a distance from gable end west in direction to gable end east, and 6 meter, the distance from the eave to the mast. Okay, now we come to the skylight. Double-clicking the skylight, enter the dimensions, 1.8 by 2 meters. And the position should be, I think it was 4.1 and 3 meters. And now again, I would like to use the copy function, right mouse click, copy. The clipboard will be visualized, and from within the clipboard, I drop it here on the right-hand side of the roof. Then I have to check the position. Y is still the same as 3 meters. Both windows or both skylights are on one line. And for X, it's 10.2 meters. Okay, and now we have defined 2 shading objects as well as 2 restricted areas. And now we come to the next step, and this is the module coverage. And here, of course, we have to select the module first, and therefore we have to press this small triangle here on the upper left-hand side. And then we have to use this one here, select edit reference module. If you would like to select a new module, and then we can use different options. We can use this drop-down menu. Then we will have access to the huge database, to all manufacturers, to all module types, but you can limit down the number of companies if we check the box, manage selection favorites, and then also only the dummy module and our favorite module, which we have added to the favorite list, is available here for selection, and then it's very quick and easy. Another option would be to use a detailed selection. Then you have to press the icon on the upper right-hand side, and then the whole database will be visualized on the left-hand side, all available manufacturers, and on the right-hand side in the big window, these are the corresponding module types. Yeah, sometimes one module type is not available in a database, then you have to wait until the next module and inverter database is normally is every 2 weeks, but you can also add modules by yourself. What you have to do is you have to press a new button, or you can also press a copy selection button. And then you can overwrite all entries via using the data sheet. Okay, that's it for the module selection. Okay, then we have to decide about the module installation in vertical direction or in horizontal direction. We use the vertical direction, then we have to close this dialog, and now we can start covering the roof. And again, different options are available. You can do it via drag and drop for each single module. Another option would be to fill an area. If you select fill an area, then you have to decide about the module distances in horizontal and vertical direction. And afterwards, you can open a frame, and only this frame will be covered with module. And the third option is to cover the entire roof, taking into account the shading objects as well as restricted areas. No, it's unfortunately not centered here on the roof. This can be done via double-clicking one of these modules, and here on the lower left-hand side, you can enter the X and Y coordinate of your PV field. And again, point of origin is the lower left edge of the roof. And this should be 0.5, and this should be 1 meter. Now it's centered around of these two skylights. One of the big advantages here in the 3D visualization is that you can take into account shading objects which are on top of the roof, close to your module field. And the first step to get an impression about the shading is that you can calculate here the shade frequency distribution. If you press the calculate button, then you will get a percentage value for each modules, and this is direct irradiation reduction over the year. Close to the chimney and close to the parabolic antenna, we have the highest values from of 12.7 and 15.5%. And this is a direct irradiation reduction over the year. It's not the same as a yield reduction due to shading. This will come later on. Now you have to decide if you would like to remove these here from your PV field. And this would be possible if you mark this module with the left mouse, and then you can open the context menu, remove. Or you can also mark these and use Enter as a delete button on your keyboard. And now it's again symmetric. Okay, that was the flush mount installation on a saddle roof, and now we change to a flat roof, and there we would like to have an assembly system, a roof mounted system, and therefore we have to change from module coverage to module mounting. Okay, then we have to change the buildings from building 1 to building 2, and now building 2 is activated, and we can start defining an assembly system for building number 2. Again, press the small triangle, select Edit Assembly System. We have to define a new assembly system, and now you have the choice between a PVSOL assembly system orientated to one direction, and the second option is that you can create an east-west tilted system. And we prefer here option number 1. We would like to have an assembly system orientated to the south. And now we have to go further with selecting the module. This is the module we have used for our flush mount installation, but this is in a vertical orientation, and we would like to change this in a horizontal orientation. Therefore, you can press the icon here on the right-hand side, and then it will be changed automatically from vertical to horizontal. And now, how to create the assembly system. This is divided here, separated in three parts. The upper part is to define the module mount. The part in the middle is to define the orientation of your assembly system, and the lower part is to calculate the optimum row distance to minimize the inter-row shading. Yeah, we will start with the module mount. Here, this is the number of modules in a vertical direction. Yeah, up to 6 modules each above the other is possible for your module mount. This is for the spacing between the modules here on your system. And this is the distance from the bottom edge of the module to the roof. To the roof or to the ground in case of open field installations. Yeah, then we come to the orientation. We would like to have an orientation, I think it was 20 degrees, 16.
Yeah.
So look. Yeah, it was 20 degree. All entries we made here. We make here, this is for the assembly system, 20 degree. On the orientation of our assembly system to the mounting surface is 0, because our building is orientated to south, and our assembly system should also be orientated to the south. Therefore, the deviation is 0. If you would like to have an assembly system orientated to the east, then you have to enter -90. And if you would like to have an assembly system orientated to west, then you need to enter here +90 degree. Here under calculate, you have the option to enter the resulting module inclination and the resulting module orientation. Yeah. Before we have entered the inclination and orientation of the assembly system, and here you can enter the resulting module inclination and orientation. Yeah, and because we have a roof pitch here, the inclination of our mounting surface of 5 degree, yeah, and in addition to our mount angle of our assembly system of 20 degree, we have in sum an inclination of 25 degree. And the orientation of our mounting surface is 180, and it's the same here for the module orientation. And the orientation of our mounting system, compared to our building, is 0. Okay, that was the part in the middle, the orientation. Now we come to placing to calculate the optimum row distance. Therefore, you have to press the calculate button, and here we are. Based on a 21st of December at noon. Yeah, this is a winter solstice on the northern hemisphere. For this date and time, will be calculate the optimum distance between the rows so that you would have no inter-row shading. Of course, for the southern hemisphere, it would be the 21st of June. And the resulting mounting support clearance is close to 80 centimeters, 0.8 meters. Okay, now our system is defined. We can confirm it's okay. Close this dialog, and now we can start covering the roof. And as for the module coverage, you can also add here single rows of modules, single rows of our module formation. Now here's entered 5 modules in a row. Yeah, that would be possible here. You can do it manually, each by each, or you can also use the second button here, and this is to cover the entire surface with a maximum number of modules per row. And here we are, 3 modules would have place here on top of our flat roof. Okay, to define the position, please do a right mouse click, edit array, and here we are again on the lower left hand side. You can enter the position for X and Y, and point of origin is the lower left edge of the roof. It's 0.2 and 0.5. and now it's centered. Do we have any questions, Sixtens? Do we have to make a break? No? Okay, then we can go further to module configuration. And again, we have different options to configure the modules here. Now I have changed back to building number 2. And we have 3 options. Option number 1 is that we can configure all modules only from this PV area. Option number 2, this is to configure all unconfigured modules from building 1 and building 2. And option number 3 is that you are able to group modules which have the same orientation as well as the same inclination. Yeah. Then these groups can be combined to minimize the needed number of MPP trackers. Okay, we start with configuration only here for this installation. Yeah, you have to press this first icon here, and then we are on an inverter window. This is building number 1 with the flush mount installation. And here you have the option to get a suggestion from the program. And another option is that you can calculate configurations. If you use option number 1, suggest configuration, you have to do a selection of inverters first. Otherwise, it would be calculate the best configuration of 4,000 inverter types. And now I limit down the number, and I select the manufacturer SMA. For example, here we are, SMA. And all these inverters are pre-selected via pressing here this button, select all, or you can check the boxes you want. I select all of these, and from this selection of inverters, you will get the best solution. You will get the suggestion from the program, and this is SMA Sunny Tree Power 10,000 TH20. And this is the configuration for MPP Tracker 1. One string is 22 modules in series, and for MPP Tracker 2, also one string or 22 modules in series. If you would like to adjust these configuration, you can use these drop-down menus to change the inverter type. You are also able to change the number of modules in series. These are all options that are available in the design range. And the minimum number of modules in series is 7. And if we enter here, for example, 6, it's not allowed. Then you are in a restricted area, and you will get here immediately a red cross. This means, you have to check the system. And also you will get here a message on the bottom edge of the window. And if you look to check system, then we can see here what's wrong. And if we have only 6 modules in series, then we are outside of the MPP voltage range of the inverter. Okay, let me change it back to 22. Everything is fine. And then can say OK. And here we are. Now our first building is configured. To show you the second option, therefore I have to remove here this configuration. Okay, now it's removed, and now we check here. I show you option number 2. If you press icon number 2, then we will have here 2 buildings, building 1 and building 2. And I would like to combine these 2 roof areas, and therefore you have to click the control key on your keyboard. And with the left mouse, you have to mark building number 2, and then both buildings are marked in blue. And this small icon here is activated. And this is to configure the selected module areas together. And now these both are combined. And now we can look again or search again for a suitable inverter. And here we are. Now it's the Sunny Tree Power 12,000 TL20. And on MPP Tracker 1, we have 2 strings with 22 modules in series. And on MPP Tracker 2, 1 string is 15 modules in series. This is the mounted installation. Okay, and the second option, this is that you can calculate configurations. Yeah, if you press this icon on the upper right hand side, again you have to pre-select the 15 inverters. The inverters, yeah. We have pre-selected the SMA inverters, and if you press afterwards the start button, then the configurations will be calculated, and here we have only 3. We can use the Sunny Tree Power 12,000, 15,000, and the Sunny Tree Power 17,000 TL10. And here we have different bars, different colored bars, and this represents the areas. Yeah, in yellow, this is the tolerance range. In green, this is the design area, and again the tolerance range. And this can be defined in the configuration limits. Yeah, here we are. This is regarding the sizing factor, and yeah, below of 80%. Here we are in a restricted range from 80 to 19. This is the tolerance range from 90 to 110. The design area, followed by a tolerance range from 110 to 120%, and above of 120 again, the restricted range. Yeah, if you have other information, maybe from the manufacturer, you are able to override these settings, and yeah, then you can use it. Also here in the next tab, here you are able to change the maximum system voltage for our customers in the US. You can enter 600 volts, for example. Okay, yeah, that's it for the configuration. Yeah, now we have to adopt data, another option. Yeah, we can explain another option. It would be here, the small camera icon. Here with the small camera icon, you can create screenshots, which will be available in a presentation report. And this can be done here for all different tabs, shaded environment, module coverage, module configuration. And therefore you have to press here the shutter release button, and then it's taken. And yeah, that's it for the 3D visualization. And now we have to adopt the data. And therefore we have to press here the small icon on the upper left-hand side, project administration. Here you have also the option to save the project. Again, check the system. And to leave the 3D visualization, you have to press adopt data, and then you will be asked, yes, you would like to adopt these, and we also would make to run a yield simulation, and then the module shading ratios have to be defined, and yes, now it's running.
Yeah, and what does it mean? So it's now the real shading simulation which takes place, and so this means for every single module the program calculates where are the shading objects, where's the sun, and how's the shading on the module, also on parts of the module. Then if you have to take into account the bypass diode on the module and how this will change the characteristics of the module, then how will a shaded module influence the whole module string, and of course the MPP tracking on the inverter and all this kind of stuff. So it's very complex, and you get a very detailed shading analysis for the project. Yeah. Okay, this is done now, and we can change to the next planning step, and this is for the selection of the battery systems. And what you can see in the upper part, you can just select a complete storage system. So there are, well, it's the well-known selection tool here for products from our database. So here you have the company list. In our case, we select company BAE, and they have different products available, and in our case we select the SunDepot 48-210. If you have selected this, then you can just go to the next window. There's nothing more to do, so everything is predefined. Yeah, last week we showed you what you can all define here. Maybe a few words to this. So a battery system consists basically on two different parts, and this one part is the battery inverter, which is here on the left-hand side to charge and discharge the battery, and you would have to enter all these values if you want to create or define your own system. And the second part, of course, is the storage unit, and it's the battery, in fact. And here we would have to select one of the batteries, maybe from the database here under the select button. It's pretty similar to the selection of the inverters and the modules. And of course, you would have to define the number of batteries per string or the number of battery strings. If you want to define your own system, then you can, of course, you have to enter all these values. You can also overwrite the small fields here, which you can see here, the drop-down menus. They can be overwritten. You can enter here the company name and the model number, and then here the save button right to the drop-down menus is activated, and you can just use it, and then it's saved and stored in your database, and you can use it for future plannings. Okay, so that's it for this page, and we go to the next one. This is for the cables. Again, last week we showed a detailed entry. Today we make it very, very quick and just enter the total loss. Yeah, and in our case it's 0.34%. Then we go to the circuit diagram. So here's nothing really much to do. It depends on the selected system or the defined system. You can only choose if you want to see with the legend on the title block. This can be exported to a PDF, or you can export it to a so-called DXF format. So this is for using in the CAD programs. If you want to work with it in your CAD program, you have to add something or to delete something, etc. Yeah, so that's it for the circuit diagram. And we can come to the financial analysis. So here we have to enter the costs of the system, of course, and maybe something that we get for our production.
Yeah, so we have to press the edit button, and first you have to enter the assessment period, complete years. Below you can take it into account the annual average return on capital employed. Here you can take into account the loss of the value of the money. €1,000 now is not the same as in 10 years or $1,000. On the bottom edge, this is to remind you that you have to enter all entries as gross or as net. Don't switch between both options. And then we can go further to the income and expenditure. We have entered here the total investment cost of our system, and we have entered our components here as detailed entry here on the right-hand side. If you check the boxes detailed entry, then you can define here different positions, and we have defined here the PV system, the BAE storage, as well as the Sunny Island with the period of life. We have also taken into account our incoming subsidies here in Germany from our government. It's €1,560. We would like to take into account here an outgoing annual cost of €100 per year. There are other options available. You can enter another specific value, euro per kilowatt peak and year, or percentage of investment per year. And of course, for all these data, you can take into account inflation. If other costs are available, or annual consumption costs or outgoing annual costs, if you have to rent a roof, or if you would like to define insurance separately, then you would have the option here. Then we go further to financing. Up to 3 loans are possible. We're using one loan with 80% loan capital, 80% of the investment. The term of our loan is 10 years. We don't have repayment-free initial period. It's an installment loan with a loan interest of 2%, and the repayment period is quarterly. Of course, other options are available: monthly, half-yearly, and yearly. And if you want, you can also take into account tax and depreciation. Okay, now we come to the yields, to the income. This can be done here.
Yeah, so there are two different ways to earn money for your PV production, and one is, if you have it in your country, is a feed-in tariff. So you feed in something and then you get paid for it. And yeah, this can be, feed-in tariffs can be added here, and go to the add button, and there are some predefined in the database. Basically, of course, for Germany, so not able to create them for all of the countries of the world, but you're also able to create your own climate feed-in tariff here by using this new button here. So if you click on it, then you have to enter here all the different. You can select the country. If it's only available in a city, you could enter here the city name, type of installation, just give it a name here. Then the important thing is here to enter value from date and the payout duration. So in Germany, it's for example 20 years. And on the right-hand side here, there you can enter different tariff bands for. Well, this is now from the production from 0 kilowatt peak hours, but if you have maybe larger systems, maybe 10, and you get less money or more money for that, for example, 10 kilowatt peak system, then you can enter here some values and so on. What else is here possible? You can also define something for the own consumption if you are paid for that, and for remuneration. If you have to pay for it, like it's in Germany, then you have to select here the output. It's pretty similar to the definition of the feed-in tariffs. And also in the lowest part here, the generation tariff, then you get paid for every kilowatt hour which you produce. It's going to also be entered here. So for example, in the UK. Okay, so let's cancel this here, and then if you click OK, then you save it in the database, and we will cancel it, and we will select the current tariff which we have to use, and this is here for October 2015. It's also possible to add more than one feed-in tariff if you have maybe different ones for different years. For the first 5 years you have one, and sort of year 5 to 10 you have another one, and you could just add it here, and then it will all take into account in the simulation. Yeah, you can also define inflation rate for feed-in tariff if it is possible in your country. Second option to earn money is, of course, we save some money because we don't use or we use less from the grid. Yeah, so and for that, for the savings, we have to define a from-grid tariff. Yeah, so can again be selected in the database. They can also be created by yourself for your specific situation. This the tariff how it look like. Another part again, you have to select the country, and you can enter a city name, the energy supplier. You can also create your own energy supplier here. Give it a name, and the base price. But the most important thing here is to define the energy price. That's the thing the money which you save probably. In our case, it's 22.2 euro cent per kilowatt hours. Okay, close this here. And of course, we can enter an inflation rate here for the energy price. In our case, we enter 4%. Yeah, that's it for the planning. So we have defined our system. Now we can make a simulation and calculate our yield and all the financing and all this kind of things. And what we will see first is an overview about the results with a graph, and here we are.
And here on the upper left-hand side, here are the key figures for the financial analysis: the internal rate of return on capital resources, the total payment from the utility, as well as a accrued cash flow balance and the energy from grid. And on the upper right-hand side, these are the key features about the technical quality of your system, with the total produced energy on the AC side, the specific annual yield, as well as the performance ratio. Here below, this is a balancing diagram over the zero line, what goes into the system. Of course, this is PV generator power, as well as battery, the battery energy. And below of the zero line, this is what goes out from the system. This is consumption, what we fed into the grid, and what we have used to charge a battery. And of course, due to the regulation, at the feed-in point, that 60%, only 60% we allow to fed into the grid, and if it's more, then it will be regulated. If you would like to have a more detailed information about your simulation, then please have a look here on the upper left-hand side. Click simulation in the T view, and here we'll get information separated in 3 parts: PV system, appliances, and battery system. And here you can see again what will be produced, what is your own consumption, what you have to fed into the grid, how many would be regulated, and how many can be used for charging the battery. This is our own power consumption. It's close to 31%. And if we have a look to the appliances, the total consumption is 5,020 due to the standby consumption and the batteries charging off the grid. And from these 5,020 kilowatt hours per year, 2,075 will be covered by the PV power, and also 1,730 will be covered by the battery, so that we get the level self-sufficiency of around 76%.
If you need a much more detailed view on all the results, you can use the diagram editor here. You can select for every simulation result here from the data series menu, and you can define the intervals if you want a weekly resolution, and it's up to a daily resolution. You can select the dates if you want to show it, and you can copy the graph to a clipboard, or you can also copy all the entries or all the values as a table and then enter it, for example, into Excel or something like that. It's also possible to show a carpet plot from that for an analysis. What else can we see in the results page? There's, for example, the energy balance of the system for a quick or short overview about the gains and losses in the system, beginning at the global irradiation onto the horizontal, down to the power which comes to the AC grid. Then we have, of course, the financial analysis here, and this shows us, for example, the amortization period. It's about 10 years, and this time the internal rate of return. It's about 16.6%. Then we have, of course, information about our costs and about our income here, about our savings and what we get for the fitted. It's in the lower part. This can also be shown in a table, so for every single year, for a period, and we have also cash flow balance graph here. So all the results and also the planning can be shown in a presentation report. We can configure this report under the configuration link, also to decide what should be in, what should be out. Just mark it with the hook or uncheck it, We can select different languages compared to the program languages. There are some additional ones like Danish, is it Turkish? I think it's Netherlands and Swedish. You can also decide if you want to have a higher resolution of the pictures in a PDF, if you wanted to export it to a PDF. Of course, this results in a larger size of the PDF file. As I mentioned, you can export it to a PDF or to a Word file. And on the show, we can see how a presentation report looks like. And, you have a front page with all the entries from the beginning of our project planning, from the project data. Then we have here some information about climate data and how it looks like, our system. Then the general results, so the important results here, the produced energy, the yield, and so on, and then some information about the different used modules and so on for the different fields. Data sheet from the module, the inverter, the energy balance is in, and so on. All this kind of things which we have seen in the results page. And of course, we should have our screenshot, which we have made at the end of our planning in a 3D visualization. Here we are. That's it. Okay, this one, of course, can be printed out. And now we are at the end of our planning and at the end of our webinar. That's what we would like to show you. I hope you enjoyed it and you are now able to plan your own system or your very own system. If you need some more information about our programs, please take a look at our website, www.valentin-software.com. If you have some additional questions to us or some remarks, please write us an email to webinar@valentin-software.com. That's it from my side. Bye-bye.
I also have to thank for your attention, for your time and your interest. Have a nice evening. And goodbye. Take care.